Hey guys, welcome to lecture number 3B of electric charges and fields. In the last lecture, we have learned about electric fields and electric field lines. So, in this lecture, we will be doing some NCERT based questions on the topic electric charges and field lines. Keep in mind that all the questions we discuss here are important and similar pattern will be asked in exams. So, study these problems really well. Okay. Now, moving on to first question. Question number 1. An electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude 2 into 10 raised to 4 Newton per Coulomb. The direction of the electric field is reversed, keeping its magnitude unchanged, and a proton falls through the same distance. Compute the time of fall in each case. Contrast the situation with that of free fall under gravity. See, before answering this question, I want you to learn about how charge particles, that is positive and negative charges, behave in the presence of electric field. Suppose in this region we have electric field in this direction. Okay, what does this mean? We know that from positively charged particles, electric field point radially outward. So this electric field might have been produced by a positive charge on this side at an infinite distance, or by a negative charge in this side at an infinite distance. See, it might have been produced like this, or by like this. Okay, so suppose this electric field was produced by this positive charge. If we keep a unit positive charge here, this positive charge will be repelled by this positive charge. So as a result, the positive charge will move in this direction. Now consider the other case. This electric field was produced by this negative charge. So this positive charge will be attracted by this negative charge, and in this case also this positive charge will move in this direction. So what will be the case if a negative charge is placed in this field? If the field was produced by this positive charge, then the negative charge will be attracted by this positive charge and will move in this direction. And if the field was produced by this negative charge, then this negative charge will be repelled by this negative charge and in this case also move in this direction. Okay, so what's the conclusion? The conclusion, we can note that a positive charge placed in an electric field will move along the direction of field, and a negative charge placed in the field will move opposite to the direction of field. Always keep this in mind while answering a question. Okay. Now coming to question number 1. See, just like we said, the electron will move opposite to the direction of field and the proton will move in the direction of field. The question says that the electron falls in a uniform electric field of magnitude 2 into 10 raised to 4 Newton per Coulomb. Therefore, the magnitude of force experienced by the electron Fe will be given by Fe equal to E into capital E, where capital E is 2 into 10 raised to 4 Newton per Coulomb, and E is the charge of electron. Also, by Newton's second law, F equal to ma, where m is the mass of electron and a is the acceleration experienced by the electron. Therefore, we can rearrange this equation as acceleration of electron is equal to root of E into me. The question is to find the time taken by the electron to fall through a distance of 1.5 centimeter. Using Newton's equations of motion, S equal to ut plus half at square. Since it says that the electron is falling, the initial velocity u will be 0. Therefore, this term will be 0. Therefore, this equation reduces to S equal to half at square. Rearranging this equation gives us T equal to root of 2s by a. Therefore, the time taken by the electron to fall through a distance s will be root of 2s by acceleration of electron, which is this quantity, which is E into me. Plugging in the values gives us 2 into 0.015 meter into mass of electron, which is 9.11 into 10 raised to minus 31 kilogram, by charge of electron, which is 1.6 into 10 raised to minus 19 coulomb, into magnitude of electric field, which is 2 into 10 raised to 4 Newton per Coulomb. On computing, we get this value as 2.9 into 10 raised to minus 9 seconds. Proceeding in the similar fashion, we get that the time Tp taken by the proton to fall through 1.5 centimeter will be given by 2s by ap, where ap is given by ee by mp. Plugging this value here, we get 2s by ee into MP. Now computing the value, we get it as 1.3 into 10 raised to minus 7 seconds. Hence, we have completed the part B of question also. Now, one thing you might have noticed is that I have neglected the effect of gravity in these computations. Why? To answer that question, we should calculate the acceleration on proton and electron due to the electric field. Using this equation, AP equal to EE by MP. On plugging in the values and calculating, we get it as 1.9 into 10 raised to 12 meter per second square. We can see that this value is enormous compared to the acceleration due to gravity, which is 9.8 meter per second square. Similarly, if we calculate the acceleration for electron due to electric field, it will be an even larger value than acceleration due to proton. That's the reason why we neglected the effect of gravity in this question. Okay. Now, moving on to the second question. 2 point charges Q1 and Q2 of magnitude plus 10 raised to minus 8 coulomb and minus 10 raised to minus 8 coulomb respectively are placed 0.1 meter apart. Calculate the electric field at point A, B, C as shown in figure. Now, to calculate the electric field at point A by Q1, we know that the electric field produced by Q1, which is a positive charge, will be in this direction. Therefore, the direction of electric field at point A due to Q1 will be in this direction given by EA1. Similarly, the electric field produced by this negative charge will be in this direction. Therefore, the direction of electric field at point A due to Q2, which is a negative charge, is also in this direction. It is given by EA2. Now, the net field at A is given by EA, which is EA1 plus EA2. Okay. We know that both EA1 and EA2 are directed towards right. Therefore, the magnitude of EA will be given by 1 by 4 pi epsilon 0 into Q1 by R1 square plus Q2 by R2 square, where R1 is the distance between Q1 and point A and R2 is the distance between Q2 and point A. Okay. Now plugging in the values, 9 into 10 raised to 9 into Q1 is given by 10 raised to minus 8 coulomb. Therefore, 10 raised to minus 8 by distance between Q1 and A, which is 0.05 square plus Q2 is given by minus 10 raised to minus 8. But since we only need the magnitude, we are taking only 10 raised to minus 8 by R2, which is 0.05 meter. Therefore, we obtain the magnitude of EA as 7.2 into 10 raised to 4 Newton per coulomb towards right. Now, to calculate the electric field at point B, the electric field due to positive charge Q1 will be in this direction and the electric field due to negative charge Q2 will be in this direction. Therefore, at point B, we get two vectors E1B due to Q1 and E2B due to Q2 towards right. Now, to find the net electric field EB at point B, we get it as E1B minus E2B. Therefore, magnitude of EB is given by 1 by 4 pi epsilon 0 into Q1 by R1B square minus Q2 by R2B square. Plugging in the values gives us 1 by 4 pi epsilon 0 as 9 into 10 raised to 9 into Q1, which is 10 raised to 8 by R1B, which is the distance between Q1 and B, as 0.05 meter. Therefore, 0.05 meter square minus Q2, only the magnitude of Q2 is taken, therefore 10 raised to minus 8, sorry, this was also 10 raised to minus 8 coulomb by the distance R2B, which is given by 0.05 plus 0.05 plus 0.05, which is 0.15 square. On calculating, we get magnitude of EB as 3.2 into 10 raised to 4 Newton per coulomb. This is the net electric field at point B. Now, we need to find the electric field at point C. See, due to this positive charge, the electric field at point C will be in this direction, and due to this negative charge, the electric point at point C due to Q2 will be in this direction. Therefore, electric charge at point C is given by E1C and E2C. Also note that using exterior angle theorem, the angle between these two vectors will be 120 degree. Why? This is 60 degree and this is also 60 degree. Note that the magnitude of Q1 and Q2 are same. Also, the distance between Q1 and point C and Q2 and point C is also same. So, the magnitude of E1C and E2C will also be same. Therefore, the net electric field due to E1C and E2C will be in this direction. And these angles will be 60 degree and 60 degree respectively. Now, resolving E1C and E2C into components, this will be the sine component of E1C and this will be the sine component of E2C. Since E1C and E2C are same in magnitude, these two will also be in same magnitude and will cancel each other. Now, the only remaining thing will be the cos components of E1C and E2C. Therefore, the net electric field EC is given by the cos components of E1C and E2C. Since E1C and E2C are same, we can write this equation as 2 into E1C into cos 60, which is given by 2 into 1 by 4 pi epsilon, which is 9 to 10 raised to 9, into magnitude of Q1, which is 10 raised to minus 8, by distance between Q1 and point C, which is 0.1 meter. Therefore, 0.1 meter square into cos 60, which is half. On calculation, we get this as 9 into 10 raised to 3 Newton per coulomb towards right. Always remember to write the direction of vector while answering questions. Okay, don't forget this, as this part carries half marks. Now, third question: a point charge QA and another point charge QB, which is QB given by minus 3 microcoulomb and Q is 3 microcoulomb, are located 0.2 meter apart in vacuum. So, the part A of the question is to find the electric field at midpoint O of the line AB joining the two charges Q and QB. Therefore, you have to find the electric field at this point. We know that QA is a positive charge and QB is a negative charge. Therefore, direction of electric field at point O due to QA will be in this direction, and direction of electric field at point O due to QB will also be in this direction. Let's name this as EA and this is EB. Therefore, the net electric field at point O is given by EA plus EB. Since both are towards right, we can take the magnitude directly, which is 1 by 4 pi epsilon 0 into QA by RA square, where RA is the distance between QA and point O, which is 0.1 meter, plus QB by RB square, which is also 0.1 meter. Now, plugging in the values gives us 9 into 10 raised to 9 into 3 into 10 raised to minus 6 by 0.1 square plus 3 into 10 raised to minus 6 by 0.1 square, which gives us 5.4 into 10 raised to 6 Newton per coulomb, and the direction of field is towards OB. Now, moving to part B of question. If a negative test charge of magnitude 1.5 into 10 raised to minus 9 coulomb is placed at this point, what is the force experienced by the test charge? We know that the force due to an electric field E is given by F equal to QE. Here, the magnitude of test charge Q is given by 1.5 into 10 raised to minus 9 coulomb into electric field, which is 5.4 into 10 raised to 6 Newton per coulomb. On calculating, we get this as 8.1 into 10 raised to minus 3 Newton. Now we have to also mention the direction of this force. See, this is a negative test charge, and we have already learned that a negative charge placed in a field will move opposite to the direction of the net field. Here, the direction of net field is towards OB. Therefore, this negative test charge will move opposite to the direction of OB, that is towards OA. Therefore, the direction of force is towards OA. Now, next question. Figure 1.33 shows tracks of 3 charged particles in a uniform electrostatic field. Give the signs of the 3 charges. Which particle has the highest charge to mass ratio? See, in question number 1, we have already discussed how charged particles behave in an electric field. Here, the direction of field is in this direction. And since charges 1 and 2 move opposite to the direction of field, charges 1 and charges 2 are negatively charged. Also, we can see that charge 3 moves in the direction of field. Therefore, charge 3 is positively charged. Hence, we have found out the signs of 3 charges. Now, part B of the question, that is to find the particle which has highest charge to mass ratio. We know that acceleration is given by QE by M, where Q is the charge of the particle and M is the mass of the particle, and E is the electric field present around the particle. Using Newton's equations of motion, we know that S is equal to ut plus half at square. Here, consider only the vertical displacement of these charges. Therefore, we know that initial vertical velocity will be 0. Therefore, this term will be 0. Therefore, S vertical, that is the displacement of the particle in vertical direction, is given by only half at square. It implies SV is directly proportional to acceleration of the particle. And we know that acceleration of the particle is directly proportional to Q by M. That is the charge on the particle by the mass of the particle. Here in the question, by observation, we can see that the highest vertical displacement is for particle 3. And since vertical displacement is directly proportional to charge to mass ratio, the highest charge to mass ratio in the 3 particles will be for particle 3. Therefore, particle 3 has highest charge to mass ratio. I hope you understood how to answer this question. If you further have doubts, please ask in the comments. Okay. Now, next question. A conducting sphere of radius 10 cm has an unknown charge. If the electric field 20 cm from the center of the sphere is 1.5 into 10 raised to 3 Newton per Coulomb and points radially inward, what is the net charge on the sphere? See, a conducting sphere is present of radius 10 cm. We need to find the electric field at a distance of 20 cm from the center of the sphere. The entire charge present in the sphere will be concentrated at the center of the sphere. Therefore, we can consider the entire charge on the sphere as a point charge at center of the sphere. Now, we need to find the electric field at this point, which is 20 cm away from this point charge. Therefore, the net field at this point due to this point charge is given by E equal to 1 by 4 pi epsilon 0 into Q by R square. On rearranging this equation gives us Q equal to E into R square into 4 pi epsilon 0, which can be again written as E into R square by 1 by 4 pi epsilon 0. Substituting the values, that is E equal to 1.5 into 10 raised to 3 Newton Coulomb into distance, which is 20 centimeter, that is 0.2 meter square by 1 by 4 pi epsilon 0, which is 9 into 10 raised to 9. Solving this gives us 6.67 nanocoulomb. Now we need to find the polarity of this charge. Since it is said that the field points radially inward, it should be a negative charge. Therefore, the polarity of this charge is negative. Thus, we can say that net charge on the sphere is negative 6.67 nanocoulomb. Okay. So guys, I want each and every one of you to go through these questions really well and try to answer these questions on your own. The questions that will be asked for exam will be very similar to the pattern we have seen here. And also try to do more questions. Okay. And if you find any difficulty in any of the questions, please post those in comments and I will be helping you in answering those questions. Okay. Thus, we have concluded this lecture, and in the next lecture, we will be dealing with electric flux. If you understood the concept discussed in this video, please like this video and press the subscribe button. Thank you all and have a good day.